we are looking today what? Friction. Now I want you to be careful about the friction because most of the students they don't know about the friction very well. Some people know the theory part and they don't know the what? The calculation part. And we are doing the part one theory part and part two what? Be the calculation part. Now, the first thing, what is friction? Now, what do we mean by friction? What do we mean by friction? Now, friction is defined as a force. What do I call it? As a force. The question that is as what? Force, know the key point. Which act at the surface of separation between two objects. Between the what? Two objects. Or two body in contact and tend to oppose the motion of one over the other. What do we mean by that? The question that you need to ask yourself, what do we mean by force? Two bodies. There is a body, two body here. This is one body. This is one body. Let me draw it very well. We have, this is one body. Now, this is like a table. Now, another body. Now, another body on top of the what? Table. This man is here pushing the what? The this is what? Body A and what? Body B. You are pushing the what? Body A on top of the what? Body B. Now, this place, if this place is between them, yes or no? If this place is rough, what will happen to the body A? The body A will not be able to move. Now, what make this thing not move very well is called friction. Clearly, that's what we call about friction. Now, we have different type of frictions. Now, you do see when we are pushing this, if this place is not smooth very well, the force cannot what? Able to what? Apply very well. But if this place is very smooth, just use small force. The what? The body A will what? Will move. Very simple as ABC. Now, you have to understand that. Now, there is what we call static friction and what we call dynamic friction. What do we mean by that? A static friction always happen horizontal like this. What we have now, look at this one. Assuming that it is, I like drawing that you can be able to understand. Now, you have a car. This is car, a beautiful car that you have. I know your car is still more beautiful than this. And you want to carry a load. Now, assuming you have let us assume that, okay, let me clean this one small because we still use that one. We have a, what do you call this one? We call, no, this is table or a flat wood that you want to place on top of this. Just, are you hearing me now? Just, this is the driver that, are you hearing me? Don't worry, just, now, let us just, now, we have, this is the load. Are you hearing me now? This is the load. This is the what? The wood. We put it on top of the wood. This is a load. A. Now, this one is, we can push this one, yes or no, and stay here. And stay here and what? Still put this one because it's flat. Okay. We are pushing. Now, if we want to raise it to on top of this place, it now become like this. Just please. Please, just don't annoy. I hear him now. I can be able to understand. Just tell you to understand. Now, what is happening here? Please, what happened here? We put this one. This one is flat already. This one we call static friction. This one, because you have raised the what? The wood with the what? Want to now he has turned to what? Dynamic what? Friction. You see it's different. The way you will solve this one is different entirely the way you solve this one. Now, what happened to this one? You have created a what? An angle between this. Look at the angle. Because when you raise this one, you have created the what? Angle. And when you create an angle, it have turned to what? What? Dynamic what? Friction. Now, for dynamic friction, we use what? This symbol. And dynamic wisdom, we use FD. And static friction, we use what? FS. Note that FS is greater than what? FD. Who can tell me the F? This one is what? It's called what? F what? S. What do you call this one? F what? FD. Now they are saying that this one is greater than this one. How? That okay, the what? Know that Fs is greater than what? This. How it is greater than? We look at it one after the other. Do you know how the way it is greater? Let me show you. Now, you know this one is flat already. If you want to put this one now, you are pushing this one. Now, what happened? When you are pushing this one, now let us put this one. Two things happen in this place. Number one, what can make, we are looking at the flowing of the what? The flowing of the what? Of the friction. That's what we are looking. And remember, I've told you that physics is what? Dealing with a body. It's dealing with what? A object. Two what? Object. What happened to that two objects that make something happen? That's what physics is dealing with. Now, this one, the friction of this one, because it's what? Flat. Now, look at this one. Two things happen here. Now, number one, they raise it up. What will happen to this one? It will go back. The object of the A, what will happen to the object of the A? It will try to what? Go down. I hear them now. This one, it will try to pull back. What will happen to this, to the what? Now, there is two things. The object, because you raise this one, it creates the angle, it will be sliding back. Another one, there is something happen here again. Because there is friction. The friction will not let the what? Object move forward. What? Limiting the friction of what limiting the flow of this one? Number one is what? The what? The lifting of the what? Of the object, creating an angle. And again, the friction here again is still limiting. I get it now. It means that there is two things that is limiting this one. Number one, the sloping of the what? Of the object. And the what? The friction. I hear him now. That's the two. But look at this one. What is the thing that this one is limiting this one now? The what? The friction. And it is what? It is balanced. That's why we cannot relate this one together. We need to solve it differently. That's why in this place, we'll be looking at this one after the other. How can we know? What do we understand? And how can we solve the formula of all these one after the other? Do you understand it very well? Now, that's how the what? The friction. And God bless you. Let us move to the next. This one what? Can you tell me? We call this one what? Static friction. When you see like this one, it's called static friction. And static friction has what? Has what? Weight, normal what? Normal friction, and direction of force. We can use this one as what? Force. You can even push it back. Anyone, whether front or backward. Anyone. And now the calculation, we use this formula. Coefficient of a static friction. We use this symbol. And F represent friction force. And this one we have normal force. Now, anywhere you see static friction, As I've already told us in the previous video, it's the same thing. Now let's look at the example that you can really understand. Notice that when you are pushing this one, what are we looking here? We are looking the friction. When a two objects they collide to each other, what make that thing to be not what affect the both of the body. This is body one, body A. The surface is another surface which is down. It's called what? Body B. Now this one want to slide on top of the body B. Now what are we looking at is the friction between them. What affect them? What affect them that will not let this one move fast? Are you hearing me? What are the things that reducing the motion, the speed of the of the body A and body B? That's what we are looking. Notice that. Now let's all look at it. Now let's all look at this one to look at the example. Calculate a magnitude of a force. Calculate the magnitude of a Of a force. Calculate the magnitude of a force required to just move how many? 20 kg object along a horizontal surface of a coefficient of friction is this. Now, in physics, you must understand that when you are reading, make sure you write all the apparatus. Put it down. All the things that they are mentioned. Put it down. Calculate the magnitude of a force. Say you should calculate the magnitude of a force. We don't know. Now, required to just move the object. Now, what is the object? Now, the force, when you are reading in what? When you are reading in whether you want to do your exam in JAM or any other thing, make sure you read all of them, finish. Read it first before you begin to put all the anything that they are mentioned. Do you know the reason why you need to read it? When you are reading it, you can able to know that whether it is dynamic friction or static friction. But when you are just writing at the end of the day, you don't know. Are you hearing now? Now it will not be what? Now it will not be what? Now we have the mass. They give us the mass. Mass is equal to what? 200 kg. What is this one? Now the horizontal surface, if the coefficient is what? They give us the coefficient equal to what? 0.34. Now we lack something. Now we must understand that the normal we have normal friction is the same thing as what? Weight. This one is the same thing with this one. Notice that this one is the same thing as what? They are together. It's still the same thing. What is weight? Weight is what? mg. Notice that. Now it means that r equal to what? mg. And what is our m? They are giving us. Remember that g represents the gravity, and the gravity is what? Meter per seconds what? Square. Now put it in this place. We have what? We have 10. We have 200 times what? 10. It becomes what? 2,000. Now 2,000 Newton. Make sure you in physics, but you are doing JAM. We need the what? The unit. When you are doing your WAEC, people that are doing WAEC. Now, after that, remember they are asking for this. That's why we apply this formula. The formula is what? Friction equal to what? F all over what? R. What is our this? 0.34. 0.34 equal to what? F. What is our F? We don't know. F. Our normal friction is what? 2,000. You now cross multiply all over 1. Our F, can you tell us the answer now? It now be 0.34 times 2,000. And what is the final answer? What is the final answer? The final answer is what? 680 Newton. Correct. All right. Let us go to the next topic, which is called what? Dynamic what?